students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as wave theory. Take down a sum please. A light of wavelength 6000 Armstrong units, a light of wavelength 6000 Armstrong unit is incident on a water surface of refractive index 4/3. Find the wavelength and frequency of light in water if its frequency in air is 5 into 10 raised to 14 hertz. Now let's see this. As light moves from one medium to another, its frequency remains unchanged. That means frequency in air should be equal to frequency in water, right? Now, I can say that I'll therefore get frequency of light in water is going to be 5 into 10 raised to 14 hertz. So first part of the question solved, find the frequency of light in water. Now I need to find the wavelength of light in water. Now, I can say that refractive index of water with respect to air is velocity in air upon velocity in water, which is also equal to wavelength in air upon wavelength in water, right? Now they have given you that. In that case I can say that refractive index of water is wavelength in air upon wavelength in water is equal to wavelength in air upon refractive index of water. So wavelength in air is 6000 into 10 raised to minus 10 upon refractive index 4/3. You can do your calculations now and get the answer. You should get the answer for this as 4500 Armstrong unit. Next, take on next sum please. The refractive index of glass with respect to water is 9/8. The refractive index of glass with respect to water is 9/8. If the velocity and wavelength of light in glass is 2 into 10 raised to 8 meters per second and 4000 Armstrong unit, find the velocity and wavelength of light in water. Now first of all I can say that refractive index of glass with respect to water is velocity in water upon velocity in glass, out of which this is given to me as 9/8. Velocity in water is not given to me. Velocity in glass is given to me 2 into 10 raised to 8. Therefore I can find out velocity in water, that is 9 into 2 into 10 raised to 8 upon 8. So I'll come to know the velocity of light in water. Once I know this, Next, they've also asked me to find out the wavelength, right? I can say that as light travels from one medium to another, its frequency remains unchanged. Frequency remains unchanged. That means I can say frequency in I can say that frequency in water should be equal to frequency in glass, right? But we know that velocity is equal to frequency into wavelength. Similarly, I can therefore say that frequency in water is velocity in water upon wavelength in water. Similarly, I can say that frequency in glass is velocity in glass upon wavelength in glass. Equate the two. If I equate the two, I will get this as CW upon lambda W is equal to CG upon lambda G, right? Out of which I already know CW, I have already found out. CG I know, lambda G I know. The only unknown is lambda W. I should be able to find that out. The answer for this should be CW is going to be 2.25 into 10 raised to 8 meters per second, and lambda W is going to be 4500 Armstrong unit. Next, take on next one please. The refractive index of water. The refractive index of water for red and violet colors. The refractive index sorry, the refractive index of water for red and violet color is 1.325 and 1.334. The difference between the velocities, find the difference between the velocities, find the difference between the velocities of these two colors in water. Find the difference between the velocity of these two colors in water. Given velocity of light in air is 3 into 10 raised to 8 meters per second. Now, let's see this. They give me refractive index of water for red color is going to be nothing but velocity of light in air upon velocity of red color in water, right? Next, in that case, I can therefore say that velocity of red color in water is velocity of light in air upon refractive index of red color in water. Similarly, I can say velocity of violet color in water is velocity of light in air upon refractive index of violet color in water. They've asked me to find out the difference between the two. So I can therefore say that velocity of red color in water minus velocity of violet color in water is Ca upon refractive index of red color in water minus velocity in air upon refractive index of violet color in water. Fine, do we get this thing clear? Now, you can subtract this and get the answer. You have Ca, you have the refractive indexes. You can take Ca common and solve the equation and get the answer. You should get the answer for this as 1.528 into 10 raised to 6 meters per second. Next, take on next one please. The difference in the velocity of light, in glass and water, the difference between the velocity of light in glass and water is 2.5 into 10 raised to 7 meters per second. Find the velocity of light in air. Find the velocity of light in air if the refractive index of water is 4/3 and the refractive index of glass is 3/2. Now guys, from this it's very clear that refractive index of water is less than refractive index of glass. 4/3 is smaller than 3/2. Therefore, velocity in water will be greater than velocity in glass. That is the reason why I have written, they had only stated that difference between the velocity. Why did I write this as CW minus CG and why not CG minus CW? This is the reason why I wrote it this way. So therefore you will get larger number minus smaller number is 2.5 into 10 raised to 7 meters per second. That's the difference between their velocities. Now I can say refractive index of water is velocity in air upon velocity in water. Therefore I can say velocity in water is velocity in air upon refractive index of water. Similarly, velocity in glass is velocity in air upon refractive index in glass. Therefore, CW minus CG is CA upon refractive index in water minus CA upon refractive index in glass. You have all the values where I can say that CA is 3 into 10 raised to 8 meters per second. So you have all the values, you should be able to get this answer now, right? Excuse me? You have to find out okay, you have to find out CA in this. You have to find out CA in this. Find the velocity of light in air. CA is unknown here, right? You should get this answer as 3 into 10 raised to 8 meters per second. Next, let's see the next one. A red light of wavelength 6,400 Armstrong units. 6,400 Armstrong unit in air has a wavelength of 4,000 Armstrong units. Has a wavelength of 4,000 Armstrong unit in glass. If the wavelength of violet light in air, if the wavelength of violet light in air is 4,400 Armstrong unit, what is its wavelength in glass? If the refractive index of red and violet color is approximately the same, if the refractive index of red and violet color is approximately the same. Now, I can say that refractive index of red color is going to be nothing but wavelength of red color in air upon wavelength of red color in glass. This is refractive index in glass. Okay, they are saying that as so much in glass. Okay, next, similarly here I can say that refractive index of red color in air is going to be wavelength of red color in air is given to you as 6400 into 10 raised to minus 10, and wavelength of red color in glass is given to you as 4000 into 10 raised to minus 10. So you should get refractive index of red color in glass, right? Now once you have this, this is going to be equal to say 1.6, but they've given me that refractive index of red color in glass is equal to refractive index of violet color in glass. Therefore, I can say refractive index of violet color in glass will also be 1.6. Also, I can say that refractive index is given by the formula wavelength of violet color in air upon wavelength of violet color in glass, out of which I know the wavelength of violet color in air. So I should be able to get the wavelength of violet color in glass. 1.6 is air is 4400 into 10 raised to minus 10 upon wavelength of violet color in glass. Cross multiply and you should get this answer. Should get this answer as 2750 Armstrong unit. Next, take on next one please. The velocity of light in diamond. The velocity of light in diamond is 1.25 into 10 raised to 8 meters per second. Find the refractive index of diamond. Find the refractive index of diamond with respect to water. Find the refractive index of diamond with respect to water if the refractive index of water with respect to air is 1.33 and velocity of light in air is 3 into 10 raised to 8 meters per second. 3 into 10 raised to 8 meters per second. I'll just read the question, guys. The velocity of light in diamond is 1.5 into 10 raised to 8 meters per second. Find the refractive index of diamond with respect to water. Find the refractive index of diamond with respect to water if the refractive index of water with respect to air is 1.33 and velocity of light in air is 3 into 10 raised to 8 meters per second. Now, let's see this. Refractive index of water with respect to air is nothing but velocity in air upon velocity in water. I know refractive index 1.33 is velocity in air, 3 into 10 raised to 8 upon velocity in water. Therefore, I can say velocity in water is 3 into 10 raised to 8 upon 1.33. Once I have the velocity in water, then I can find out refractive index. What have they asked me to find out? Refractive index of diamond with respect to water is velocity in water upon velocity in diamond. Velocity in diamond is given to me. Velocity in what I have found out, I should be able to get this answer. The answer for this sum should be 1.805. Next, let's see another sum. Wavelength of light and water. Wavelength of light and water is 4000 Armstrong units. Wavelength of light and water is 4000 Armstrong unit, and in glass is 2500 Armstrong unit. Find the refractive index of glass with respect to water. Find the refractive index of glass with respect to water. Find the refractive index of glass with respect to water. Right? Now, refractive index of glass with respect to water is going to be nothing but wavelength in water upon wavelength in glass. Both the values are given to you, straightforward sum. You should get this answer as 1.6. Next, take on next sum please. The speed of light and air. The speed of light and air. The speed of light and air the speed of light and air is 3 into 10 raised to 8 meters per second. The speed of light and air is 3 into 10 raised to 8 meters per second. The speed of light and air is 3 into 10 raised to 8 meters per second. And in diamond is 1.4 into 10 raised to 8 meters per second. Find the refractive index of diamond. Find the refractive index of diamond. Find the refractive index of diamond. Now, refractive index of diamond with respect to air is velocity in air upon velocity in diamond. Straightforward sum. All you need to do is just substitute the values and get the answer. You should get the answer for this as 2.143. Next, let's see another sum, guys. The wavelength of monochromatic light. The wavelength of monochromatic light is 5000 Armstrong unit. Is 5000 Armstrong unit in air. What will be the wave number? What will be the wave number if the refractive index is 1.5? If the refractive index is 1.5, fine. Let's see this. I can say that refractive index of the medium with respect to air is nothing but velocity in air upon, no, they haven't given you velocity, they have given you wavelength. So this is wavelength in air upon wavelength in medium. Therefore I can find out, I can say that refractive index in air upon wavelength in air is 1 upon wavelength in medium. But what is wave number? Wave number is given by the formula 1 upon wavelength. Wave number is nothing but the reciprocal of the wavelength. So wave number is going to be nothing but 1 upon wavelength in medium. Therefore I can say that the wave number is going to be refractive index in air, refractive index of medium upon wavelength in air, right? You have both the values, you should be able to get this answer. The answer for this should be 3 into 10 raised to 6 per meter, right? Next sum. What is the wave number of a beam of light in air? What is the wave number of a beam of light in air if its frequency is 14 into 10 raised to 14 hertz? What is the wave number of a beam of light in air if its frequency is 14 into 10 raised to 14 hertz? Now, I can say that we know that velocity of light in air is 3 into 10 raised to 8 meters per second. Now, I can say that V, velocity, is frequency into lambda, right? So in that case, I should be able to get this as 1 upon wavelength is going to be frequency upon velocity, but wave number is nothing but 1 upon wavelength. Therefore here your wave number is going to be nothing but frequency upon velocity. You have both the values, you should be able to substitute and get the answer. The answer for this sum should be 4.667 into 10 raised to 6 per meter. Right? Take our next one, please. Calculate the polarizing angle. Calculate the polarizing angle. Calculate the polarizing angle for alcohol of refractive index. Calculate the polarizing angle for alcohol of refractive index 1.36. I can straight away use Revester's law. Revester's law says that refractive index is tan of polarizing angle. So I can therefore say 1.36 is tan theta. Therefore I can say theta is tan inverse of 1.36. Right? Look at your log table. You should get the answer for this. You will get the answer as theta is 53 degrees 40 minutes. Next, take on next one, please. When light from sun is incident at an angle of 60 degree, when light from sun is incident at an angle of 60 degrees on the medium, the reflected light becomes completely polarized. When light from sun is incident at an angle of 60 degrees on a medium, the reflected light becomes completely polarized. Calculate the angle of refraction and the refractive index of the medium. And the refractive index of the medium. Now, calculate the angle of refraction and the refractive index of the medium. Now, since the light is completely polarized, since the light is completely polarized. Now if light is completely polarized, this phenomenon would occur only when the angle of incidence is equal to polarizing angle. Therefore I can say that delta P will be equal to I. Hence I come to know that the polarizing angle is going to be 60 degree. Right, once I have this, next they have also asked you to find out the angle of refraction. I can say that polarizing angle plus angle of refraction. When polarizing takes place, when the ray of light is completely polarized, Brevister's law states that the reflected light and the refracted light are at right angles to each other. The reflected and the refracted light should be at right angles to each other. Only then polarizing will take place, complete polarization will take place. Hence I can say that the refracted angle is 30 degrees. Next, they have also asked you to find out the refractive index of the medium. Refractive index is tan of polarizing angle. So tan 60, which is root 3, which is 1.732. So your refractive index of medium is 1.732. Next, take down next sum please. The polarizing angle for glass and water. The polarizing angle for glass and water is 57 degrees and 53 degrees. Calculate the polarizing angle for water glass interface. Calculate the polarizing angle calculate the polarizing angle for water glass interface. Now first thing I can say that refractive index of glass is tan of polarizing angle for glass. Similarly, refractive index of water is tan of polarizing angle in water, right? Once you have this, then they will ask you to find out calculate the polarizing angle on water glass interface. That means I want to find out the refractive index of glass with respect to water, which is going to be nothing but refractive index of water upon refractive index of glass. I've already found those two. I should be able to get this answer. So my refractive index of glass with respect to water will also be equal to tan of the polarizing angle, because they've asked you to find out the polarizing angle, right? Therefore, the polarizing angle on water glass interface is going to be tan inverse of my refractive index, whatever refractive index I get. That's how I'll get the polarizing angle for water glass interface, right? The answer for this should be 49 degrees 15 minutes. Next, let's see the next one, guys. A beam of unpolarized light, a beam of unpolarized light is incident at Brevister's angle on the surface of a glass slab. A beam of unpolarized light is incident at Brevister's angle on the surface of a glass slab of refractive index 1.62. Find the angle of refraction. Find the angle of refraction. Now guys, Brevister's angle and the polarizing angle is the same thing. So they've given you that polarizing angle you have to find out. So I can say that refractive index is nothing but tan of polarizing angle. So therefore I can find out the polarizing angle as tan inverse of the refractive index. You already know refractive index, so you should be able to get the polarizing angle. Once you have the polarizing angle, then you can say also polarizing angle plus angle of refraction should be equal to 90 degree. So that should give you the angle of refraction. Right? Next, take on next one please. Answer for that sum should be, answer refractive angle should be equal to 31 degrees 41 seconds, 41 minutes. Next sum, show that for an optical medium placed in air, for an optical medium placed in air, show that for an optical medium placed in air, the polarizing angle and critical angle are related as cot of polarizing angle is sine of critical angle. Cot of polarizing angle is equal to sine of critical angle. If the speed of light in medium, is 1.894 into 10 raised to 8 meters per second, what are the values of polarizing angle? What are the values of polarizing angle and critical angle if the velocity of light in air, is 3 into 10 raised to 8 meters per second? Now, guys, according to Brevister's law, refractive index is tan of polarizing angle. According to Snell's law, refractive index is nothing but reciprocal of sine of critical angle. Right? Therefore, I can say from 1 and 2, tan of polarizing angle should be equal to 1 upon sine of critical angle. Reciprocate, so I'll get 1 upon tan of polarizing angle is sine of critical angle, but 1 upon tan is nothing but cot. Therefore, I can say cot of polarizing angle is sine of critical angle. That was the first part. I have to prove that cot of polarizing angle is sine of critical angle. Now, we can say that refractive index is nothing but velocity in air upon velocity in medium. Velocity in air is given to you. Velocity in medium is also given to you. 10 raised to 8. So I'll be able to get the refractive index. What have they asked me to find out? They've asked me to find out the values of polarizing angle and critical angle. So I can therefore say that polarizing angle is tan inverse of refractive index. I would have already found the refractive index here. I can also say that critical angle, I can say refractive index is 1 upon sine of critical angle. So I can say sine of critical angle is 1 upon refractive index. So critical angle is sine inverse of 1 upon refractive index. So you should be able to get both these values. Now the answer for this sum should be polarizing angle you should get as 57 degrees 44 minutes, and critical angle you should get as critical angle you should get as 39 degrees 9 minutes, right? Those should be your answers. Next, take on next one please. What is the Brevister's angle? What is the Brevister's angle for air to glass transition? What is the Brevister's angle for air to glass transition if the refractive index of glass is 1.5? If the refractive index of glass is 1.5, what is the Brevister's angle for air to glass transition if the refractive index of glass is 1.5? Guys, Brevister's angle is the same as polarizing angle. Straightforward, I can say refractive index is tan of polarizing angle. Therefore, polarizing angle is tan inverse of refractive index. You should get the answer for this. The answer for this should be 56 degrees 18 minutes. Next, read on next one please. The critical angle for a certain wavelength of light. The critical angle for a certain wavelength of light. Critical angle for a certain wavelength of light is 40 degrees. Calculate the polarizing angle. Calculate the polarizing angle and the angle of refraction for this. Calculate the polarizing angle and the angle of refraction for this. Guys, if I apply Snell's law, I can say refractive index is nothing but 1 upon sine of critical angle. So I know the critical angle, I'll come to know refractive index. Once I know refractive index, I can say that refractive index is also equal to tan of polarizing angle. Therefore, polarizing angle is tan inverse of refractive index. You already found out the refractive index, you should be able to get the polarizing angle. Once you get polarizing angle, then I can say polarizing angle plus angle of refraction is 90 degree. So that should give you your angle of refraction. So your answer here should be polarizing angle is 57 degrees 20 minutes and angle of refraction is 32 degrees 40 minutes. Next, take down next one please. Take down next one please. A parallel beam of light. A parallel beam of light is incident at an angle of 60 degree. A parallel beam of light is incident at an angle of 60 degree on a glass plate. On a glass plate and the reflected beam is completely polarized. And the reflected beam is completely polarized. what is the angle of refraction? What is the angle of refraction? Also calculate the refractive index. Since the ray of light is completely polarized, therefore I can say that angle of incidence is equal to the polarizing angle. Once I know polarizing angle, I can find out the angle of refraction. Polarizing angle plus refraction, angle of refraction should be equal to 90 degree. Once I have this, I can also find out refractive index. Refractive index is nothing but tan of polarizing angle. So you should get all these answers. Answer for this sum should be, your angle of refraction is going to be 30 degrees and refractive index is going to be 1.732. Right? This finishes this chapter. We'll stop this here for the day. Thank you very much.